Okay, grade 7, this is your continuing homework from divisibility rules in 6.1. These are questions 9 through 19, your homework. Question 9 says use the divisibility rules to list the factors of the following numbers. So if I take A and I say what are the factors of 36, what I really mean is what numbers are divisible into. So if I said the factors, that really means numbers that are evenly divisible into. Evenly divisible. That's an L. Okay? So by using our divisibility rules, the first two that we know, 1 is always divisible into a number. So 1 times 36 is one way we can get 36. So the next one we want to check for after 1 is 2. And is 36 divisible by 2? Yes, because it ends in an even number. So therefore I know 2 is a factor. And I have to figure out 2 times what is 36, and it happens to be 18. Then I say, is 3 a factor? And 3, the rule is take your digits, 3 plus 6, add them together. If you have a multiple of 3 as a sum, in this case 12, or sorry, 9, that's 3 plus 6 is 9. If that's a multiple, if this sum is a multiple of 3, then your number is divisible by 3, and it is. So therefore I know that 3 is a factor, and I know that 3 times 12 is 36. 4, the rule for 4 is if you can take the last two digits of 36 and divide it by 2, and divide this number by 2 again, if you can do that, it is divisible by 4, and in this case 4 times 9 is 36. And your last one, since I know that it's divisible by 2 and 3, the rule for 6 is if it is divisible by 2 and 3, it's also divisible by 6. So therefore we have this. And your factors of 36, if I do this little horseshoe thing here, I could follow it around. I got 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are your factors of 36. For question B, 15, it's a little bit easier. Your factors of 15. Well, we know that 1 and 15 are factors. 2 is not a factor because it ends in an odd number, so 2 is not a factor. But if I take the digits and add them together, I get 6, which is a multiple of 3, which means that 3 is a factor, and it's 3 times 5. And I know that 5 is a factor, but I already have it listed, so I'm not going to write 5 again. Therefore, my only factors of 15 are 1, 3, 5, and 15. These are the only numbers that are divisible evenly into the number 15. For question C, number 28, 1 times 28. 2 is a factor because it ends in an even number. 3 is not a factor because 2 plus 8 is 10, and 10 is not a multiple of 3, so 3 is not a factor. 4, if I can cut it in half, and then cut it in half again, yes I can. So 4 is a factor, and it's 4 times 7 is 28. 5 is not, 6 is not, and therefore I'm back to 7 again in my checking, and therefore those are my only factors. So my factors for 28 are 1, 2, 4, 7, 14, and 28. Those are all the numbers that are divisible into 28. Question 10, the factors of 18. I'm just going to do the rest right here. I'm just going to put them all out, and I'm going to show you all of the multiples of those numbers. So if we look at the factors of all of these numbers, if we make our divisibility charts, all of these numbers that I've listed here are the factors of each of them. And if I look at, let's say, 54, I knew that 54 was divisible by 3 because 5 plus 4 is 9, and I could divide, or 5 plus 4 is 9, and 9 is a multiple, so I knew 3 was. And if I look over here for 72, if I look at the number 6, I knew that 6 was a multiple of 72 because 2 and 3 were, and if 2 and 3 were, the rule for 6 is if 2 and 3 are, then 6 is a multiple as well. So those are your answers for question 10. Question 11 says use divisibility rules to determine the common factors of each pair of numbers. So this time we're going to compare 3 and 6. For 3, it's pretty easy. There's just 1 and 3. And for 6, you have 1 times 6 and 2 times 3. So the numbers they share in common, I'm just going to use my highlighter here. They share 1 and 3 and no other numbers. So therefore, I would write down common factors are 1 and 3. For question B, we have 4 and we have 8. get 4, we can go 1 times 4, we can go 2 times 2. So the factors are 1, 2, and 4. For 8, we can go 1 times 8 and 2 times 4. So we have 1, 2, 4, and 8. So the common factors we have here, 1 are common, 2 is common, and 4 is common. Those are the 3 common factors of 4 and 8. For the last one, C, for 6 and 12, 6 is 1 times 6 and 2 times 3, so the factors are 1, 2, 3, and 6. And for 12, it's 1 and 12, 2 and 6, and 3 and 4. So the factors are 1, 2, 3, 4, 6, and 12. So your common factors here are 1s, 2s, 3s, and 6. Those are your common factors. Question 13, use a divisibility rule to figure the common factors of 16. Include a Venn diagram as part of your answer. So I'm going to draw a Venn diagram. And I'm going to call this circle right here the number 16. I'm going to call this circle over here the number 20. Okay? So your factors of 16, I'm going to do it up here, and the factors of 20 I'm going to do over here. So 1 times 16. 2 is a factor. I know that because it ends in an even number, and it has to be 2 times 8. 3 is not a factor because 1 plus 6 is 7. 4 is a multiple, and it's 4 times 4. Now, if I keep going, I'm going to go back to where I was before with 8, and I don't need to. So your factors are 1, 2, 4, 8, and 16. Those are your factors of the number 16. For 20, you have 1 times 20, 2 times 10. 3 is not a factor. 4 is a factor, and that's the factors of that. So we have 1, 2, 4, 5, 10, and 20. So if I go and take my highlighter again, the common ones they share are 1, 2, 4, and that is it. So inside here, I'm going to put 1, 2, and 4. 8 and 16 are unique factors to the number 16, and 5, 10, and 20 are unique factors for the number 20. What is the greatest common factor that 6 and 20 share? The answer for that, if I take my highlighter, let's make it green this time. The greatest common factor they share is the largest number that's in common, and that's 4. And you might say, well, what's the good of knowing that? Well, let's say I had the fraction 16/20ths, and I wanted to reduce it to lowest terms. I know that if I know the common factors that each share, the greatest common factor will be one that I could reduce both the numerator by and the denominator by to create an equivalent fraction. And again, what does that mean? Well, if I take my calculator here and change 16/20ths to a decimal, 16 divided by 20 as a decimal is 80%, or decimal 8. And 4 divided by 5, the equivalent fraction, is also decimal 8. So dividing by a common factor, or the greatest common factor, will always reduce a fraction to lowest terms if you use the greatest common factor. Question 14, what are the common factors of 10 and 30? Included that Venn diagram again. So I'm going to make my Venn diagram, and I'm going to put 10 over here and 30 over here. Your factors of 10 are 1 times 10 and simply 2 times 5, which is 1, 2, 5, and 10. And for 30, we have 1 times 30. 2 is a factor because it ends in a 0, so 2 times 15. 3 is a factor, and then finally 5 and 6. So your factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Okay? So which ones do they share in common? 1 is again common all the time. 2 is common. 5 is a common factor. And 10 is a common factor. So if I'm going to list those, I'm going to put those in the middle. 1, 2, 5, and 10. All of those are for 10. There's no unique ones to 10 because those are all of the factors of 10. And the ones I put over here are 3, 6, 15, and 30. So what is the greatest common factor of 10 and 30? The greatest common factor they have is that number right there, 10, which means if you had the fraction 10/30ths, which is a third, and you reduced it by the greatest common factor, in this case 10, you would have it in lowest terms, which would be 1/3. Now let's say you didn't use the greatest common factor, but you just reduced it by a common factor. So instead of dividing by 10, let's say we divided by 5. I would create 2 over 6. which is equivalent, but it's not in lowest terms, because then I could divide it by 2, right? Which would give me 1/3, which is the answer I would have got if I divided it by 10. So 1/3 is lowest terms. So when you divide it by the greatest common factor, you get lowest terms. When you divide by a common factor, you just get a reduced fraction. Question 15, what are each of these following fractions in lowest terms? So in order to do that, I need to know which number is a common factor to both 15 and 20. You can either know the greatest common factor or just a common factor. If I look at 15, I have 1 times 15 and 3 times 5. If I look at 20, I get 1 times 20 and 2 times 10 and 4 times 5. The greatest common factor they have is the number 5. So I can reduce it by that factor and get 3/4 as lowest terms. 6 and 18, if I think about what is the greatest common factor, the greatest common factor for those two is 6. So I get 1/3 for lowest terms. Now 10 and 16 is a little tricky. Let's just check it out. 10 and 16, 1 times 10, 2 times 5, 1 times 16, 2 times 8, and 4 times 4. The greatest common factor they have is the number 2. So when I reduce it by that factor, I have lowest terms, which is 5/8. 9 and 12, I know both of them are divisible by 3. I don't know if it's the greatest common factor, but it certainly is a common factor. And when I reduce that to lowest terms, I get 3/4, which is lowest terms, so I'm done. Both 4 and 10, the greatest common factor they share is 2. So I end up having 2/5 as my answer. And finally, 9/15. I got to think of my divisibility rules. 9 is divisible by 3 because 3 times 3 is 9. 15, if I take the digits 1 plus 5, that equals 6, which means it's divisible by 3. So 3 is a common factor for both. I get 3/5 as my fraction in lowest terms. Question 16, same thing happening here. So 12 and 16, let's just look at those for a second. Question A, 1 times 12 and 2 times 6 and 3 times 4. So the factors are 1, 2, 3, 4, 6, and 12. For 16, we have 1 times 16 and 2 times 8 and 4 times 4. So the greatest common factor those two share is the number 4, right? Number 4 is the greatest common factor, which means if I reduce my fraction by 4, I will get 3/4, which is lowest terms. But let's pretend for a second that we didn't use 4, we just used a common factor. So I know by looking at those two numbers, 12 and 16, that 2 is definitely a common factor because they're both even numbers. So if I divide both by 2, I get 6/8. And that's not lowest terms because those are both even numbers again, and I could divide by 2 again. This pathway still got me to lowest terms, which is 3/4, but by dividing it by the greatest common factor, I got to 3/4 in one step rather than 2. And that's the advantage of doing it that way. For question B, hopefully you know that the greatest common factor between 6 and 12 is 6, which reduces down to 1/2. The greatest common factor between 8 and 20 is actually 4, but if you didn't know that and you reduced it by 2, you would get 4/10, and then you'd realize, hang on a second, those are both even numbers. I can reduce it by 2 again, and I get 2/5 as lowest terms. 14 and 24, I don't want to think too hard, but I know that 2 is a factor. That gets me 7/12. 7 only has 1 and 7 as, it's a prime number. It only has 1 and 7 as factors. And 12 doesn't have 7 as a factor, so that is lowest terms. 5 and 10 share 5 as a common factor, leaving you with 1/2 in lowest terms. And finally, 12 and 15, maybe a little bit tricky, but 1 plus 2 is 3, and 1 plus 5 is 6, which means both 15 and 12 are divisible by 3. And therefore, I can reduce it by a factor of 3, giving you 4/5 as lowest terms. Question 17 says a shipment of flowers has arrived at Mr. Green Thumb's nursery. He has to sort them into groups. So he has 336 daisies and 120 roses, etc. Which flowers can he divide into pairs and not have any leftover flowers? Well, those would be all of the shipments that end in an even number, which means daisies can, roses can, pansies can, and marigolds can. Marigolds. Lilies can't because it ends in the number 1. Which flowers can he divide into groups of 3? In order to do that, I need to use my divisibility rule. And once I do the sum of all the digits, I realize that the numbers that are multiples of 3, in this case 12, 3, and 6, are all of the ones that are divisible by 3. 244 is not divisible by 3, and neither is 118, but the rest of them are, which means that roses, or daisies, roses, and lilies are all divisible by the number 3. And finally, it says, what is a quick way for Mr. Green Thumb to know which flowers he could divide into groups of 6? Well, the answer is whichever ones he could divide into groups of 2 and into groups of 3 are also divisible into groups of 6, which means only daisies and roses are able to be divided by 6. Daisies and roses. The rest are not divisible by 6. Question 19 says a grocery store sells apples in bags of 8 only. Using divisibility rules, determine if you can buy exactly that many. So the divisibility rule for 6 is take the whole number and try and cut it into divided by 2 3 times in a row. So for 116 divided by 2, I get 58. Divided by 2 again, I get 29. And I know I can't divide it by 2 that last time because it ends in an odd number. So 116 will not divide by 8. 168, I'm going to divide it by 2. I'm going to get 84. I'm going to divide it by 2 again, I'm going to get 42. And I can do it the third time, which means 168 can be divided by 8. If I take my calculator, 168 divided by 8 is 21 bags of apples. And the last one, 194. If I divide it by 2, I get 82. If I divide it sorry, not 82, I get 87. No, 87? 97. Oops. I get 97. And 97 can't divide by 2 again because it ends in an odd number. So 194 cannot be divided into bags of 8. If I check my answer, 194 divided into bags of 8, I will have a decimal or a fraction of a bag left over. And I think that's all you had for homework. Okay, hopefully you got all that. Make sure you like this video, and if you haven't subscribed, make sure you do subscribe. And if you have any questions, make sure you ask them tomorrow morning.